Okay, so we have scale drawings and models. This is chapter 6.6. All right, here's our key concepts for the day. We've got scale drawing or scale model. And this is used to represent an object that is too large or too small to be drawn or built to actual size. And think about the house you're in, right? You can't draw the house that you're in right now on a piece of paper, right? So you have to scale it down to a size that is easily easily to work with. Or if you have something really, really small, let's say like an atom, and you want to, or a molecule, and you want to be able to see what is inside an atom or a molecule, so you increase it to a bigger size. And if you want to keep it really accurate, you use scale drawing or scale model. Now the scale is determined by the ratio, not ration, um, the ratio of a given length on the drawing or model to its corresponding length on the actual object. So if we look here, here's a couple examples of scales. So on a scale, 1 inch could equal 3 feet. So on your scale, you have 1 inch, and in your actual model, that represents 3 feet. Or we could have 1 centimeter equals 2 millimeters. So in this case, we're looking at something that's really small. So 2 millimeters, something really, really tiny, is going to be equal to 1 centimeter, something a little bit bigger and a little bit easier to see. So scales are written so that a unit length on the drawing or model is listed first. And then we've got scale factor. And if the scale drawing and model have the same unit of measure, the scale can be written without units. And we kind of talked about this earlier in chapter 6. And this is like, for example, the scale maybe is 1 inch to 2 feet. So we write it as a ratio 1 inch over 2 feet. And 1 inches is the same thing as 24 inches or 1 to 24, which would be the scale factor. So that makes it have the same unit of measure. Okay, here's our first example. It says, suppose a model of a dragonfly has a wing length of 4 centimeters. If the length of this insect's actual wing is 6 centimeters, what is the scale of the model? So first of all, we want to set up our proportion, okay? So we've got the model length, and we're going to set this over the actual length. Okay, so model over actual. And now from the problem, we're going to look at here, what is the model length? Well, it says the model is 4 centimeters, right? So we've got 4 centimeters over the actual, and the actual is 6 centimeters. And we're going to set this up to be 1 over how many is the actual. So what is the scale, right? We're doing 1 to whatever it is that we're trying to find. We cross multiply, we get 4x equals 6. Divide 6 by 4 and you get to be 1.5. So 1 centimeter is equal to 1.5 centimeters. Okay, you do this one. The pillars of the World War II Memorial in Washington, D.C. are 17 feet tall. A scale model of the memorial has pillars that are 5 inches tall. What is the scale of the model? Okay, you try this one and replay me when you're ready. So we want to set up model over actual. And our model is 5 inches tall, right? So 5 inches. What is the actual? The actual is 17 feet tall. And we're trying to find out the scale, so it's 1 over, we're trying to find out what that scale is, x. So we cross multiply 5x equals 17. Divide 17 by 5 and we get 3.4. So we have 1 inch is equal to 3.4 feet because our model is inches to feet. All right, here's another example. The blueprint of a skateboard ramp shows that its length is 11.4 inches. If the scale on the blueprint is 1 inch equals 6 feet, what is the length of the actual skateboard ramp? Okay, now before our questions were asking us, what is the scale of the model? Okay, what is the scale of the model? Now here, this one is asking me, what is the length of the actual skateboard ramp? So again, I want to set up my proportions. So I'm going to set up the scale, or let's call it blueprint. Blueprint over actual. And so my scale of my blueprint is going to be 1 inch for 6 feet. And I'm going to set up the blueprint saying the length is 11.4 over here in this picture, 11.4. Oop, that's a decimal. And we're trying to find out what the actual is. So we don't know what actual is, so we'll set that as an x. So we cross multiply, we get x to be 6 times 11.4. And when you do that in your calculator, you get 68.4 feet. Okay, and we can do this another way by setting up an equation. So we'll do a big or over here. We know that the scale factor, remember, is where you have the same unit of measure. So in here, my scale is 1 inch to 6 feet. And we know based on from chapter 6, earlier in chapter 6, that we can do 1 inch to 72 inches, right? Because there's 12 inches in 1 foot, and there's 6 feet, so it equals 1 inch over 72 inches, which is also the same as 1 over 72. We can write it without the inches. Okay, so this means that our actual length is 72 times the blueprint length. So I can say my actual is 72 times the blueprint. And I can plug in a 72 times 11.4. And my actual is 820.8 inches. If you divide that by 12, you'll get that in feet, which is 68.4 feet, which is the same thing we've got over here. I actually prefer the proportion way, this way here, but you are welcome to use the equation if you prefer that way. All right, go ahead and try this one and replay me when you're ready for the answer. Okay, so here we've got a map of a natural history museum shows that the dinosaur exhibit room is 7.25 inches wide. If the scale on the map is 1 inch equal to 8 feet, what is the width of the actual exhibit room? Okay, so we've got our scale over actual. Actual. So we've got 1 inch to 8 feet. Our scale is 7.25, and we're trying to find the actual width, right? 7.25. And we cross multiply, we get 8 times 7.25. And 8 times 7.25 is 58. So the length of the actual, or the width of the actual exhibit room is 58 feet. All right, now, this is, you're going to need graph paper for this one. And it says to use a 1/4 inch grid paper, but if you just want to use your graph paper and each square will count as a, let's say, a 1/4 inch. So Lila is painting a mural on a wall at the community center that measures 18 feet long and 12 feet tall. Make a scale drawing of the mural. Use a scale of a 1/4 inch equals 3 feet, and we want to use a 1/4 inch grid paper. So right now we're going to create a scale model or a scale drawing. So I'm going to set up scale over actual. And first of all, I'm going to work on my length. Okay. So I know that the scale is 1/4, the actual is 3. I'm trying to find out what the scale is for the actual length of 18 feet long. So I'm going to cross multiply. I get 3x equals 1/4 times 18. And that is 4.5 equals 3x. X equals 1.5. Okay, so this is my length. Now I'm going to look at my width. Let's make this a little smaller. Okay, so now let's look at width. We've got scale over actual. And so we've got our scale of 1/4 to 3. And we're looking for that scale. And we know that the width is 12. So we multiply here and we get 3x equals 3 and x equals 1 inch. Okay, so now it asks me to actually draw what this represents. So I've got my width being 1 inch and my length being 1.5 inch. Well, each square over here represents 1/4 inch. So if I have 1.5 inches, okay, that represents 6 squares. Well, how did I figure that out? Well, how many quarters are in 1? There's 4, right? And how many quarters are in a half? 2. Well, 4 plus 2 is 6 squares. And then I've got 1 inch. And how many quarters are in 1 inch? Well, there's 4. So there's going to be 4 squares. All right. So our width is 4. So we're going to go 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. Because our length is 6. You'll want to use a ruler on this and be really precise. A little bit more precise than I was on mine, as mine being on a smartboard. But that's how you draw a scale drawing. All right, I want you to try this scale drawing. An architect is designing a school courtyard that is 45 feet long and 30 feet wide. Make a scale drawing of the courtyard. Use a scale of 1/2 inch equals 10 feet. Use 1/4 inch grid paper. Okay. So let's look at the length first. And this is scale over actual. Our scale is 1/2 to 10 feet. We're trying to find the scale of the length, so we're looking for that. And the actual length is 45 feet long. All right, and then we solve. We get 1/2 times 45 equals 10x. 1/2 of 45 is 22.5. And divide by 10, you get 2.25 equals x. All right, then we look at our width. And we have scale over actual. 1/2 to 10. Try to find that scale for 30. And we cross multiply, and 1/2 of 30 is 15 equals 10x. Divide by 10, we get 1.5 equals x. Let me shrink this down a little bit. Whoopsies. Where are we? There we go. Group, shrink. Okay, so here we got 2.25 and 1.5. So this is really like 2 1/4. So how many 1/4 inches do I need for 2 1/4? Well, how many are in 1? Well, we said 4 quarters were in 1. So 8 quarters are in 2 plus 1 extra quarter is 9 squares. And then we've got 1.5, and we've got 4 and 1. And for 1/2, we get 2 more, so that's 6 squares. All right, So if our length is 9 squares, we'll come over here. We go 1, 2, 3, 4, 5, 6, 7, 8, 9. And we go up 6. 1, 2, 3, 4, 5, 6. And we'll make it nice and neat, as neat as possible as I can on the smartboard. And so this represents 45 feet. And this is 30 feet with a scale of 1/2 inch equals 10 feet. Okay, now here are some extra practice problems. I'll make it a little bit bigger for you. So try these as best you can, and we'll go over them next time we see each other.